Hello and welcome back. In the previous set of videos, we looked at how to extract continuous high throughput streaming data. We looked at examples of moving a server log into HDFS and also how to extract tweets from Twitter into HDFS as well. Now we will look at how to transfer structured data from relational databases. We all know by now that Hadoop MapReduce is a powerful tool. Its flexibility in parsing unstructured or semi-structured data means that there is a lot of potential for creative applications. But your analysis are only as useful as the data which they process. In many organizations, large volumes of useful information are locked away in disparate databases across the enterprises. HDFS, which is Hadoop's distributed file system, represents a great place to bring this data together. But actually, doing so is a cumbersome task. Loading bulk data into Hadoop from production systems can be a challenging task because you must consider details like ensuring consistency of data, the consumption of production system resources, and also data preparation. So before we move on, let us first look at some of the options we have to retrieve data out of structured data stores such as relational databases. You can actually do it manually by transporting the data into a CSV file and then load it into HDFS. However, this method is crude and cannot be automated. We can write programs using APIs to transfer data. This method is also very inefficient and time consuming. And lastly, you can write data directly using data residing on external systems from within MapReduce applications. This might be the better of the three options, but here even this is not ideal as it complicates the applications and exposes the production system to the risk of excessive load originating from the cluster nodes. So as you can see, these are not solutions that are elegant for transferring bulk data from databases into Hadoop. And this is where Apache Sqoop comes into picture. The term Sqoop actually stands for SQL plus Hadoop. Apache Sqoop is a tool designed for efficiently transferring bulk data between Apache Hadoop and structured data stores such as relational databases, enterprise data warehouses, and NoSQL systems. There are several scenarios why integration of Apache Hadoop with a relational database may be necessary. Scenario 1. You could actually be using Hadoop to process your unstructured or semi-structured data such as your web server logs. You could be using MapReduce to achieve that objective. However, maybe your reference and or master data such as products, customers, locations, server information, etc. is stored in a relational database. So you would need to bring in the reference or the master data into Hadoop to perform more meaningful analysis. The other scenario could be that one of the ways you could use Hadoop in your existing infrastructure is to kind of outsource the processing part of your solution, say your data warehouse. For example, your typical data warehouse follows a source to staging to data warehouse to reports kind of a flow, and this deals with a lot of data on a daily basis. So depending on the kind of processing and transformations being applied, this process takes a lot of time when done on a traditional RDBMS, and hence either your reports are being delayed and or you're not able to meet the service level agreements of having to complete the processing in a limited amount of time. In other cases, maybe you have some type of a calculation engine that is used to perform calculations such as maybe to decide if loan applications should be approved or not, and this also takes a lot of time. So in such cases, instead of performing these CPU intensive processing on your RDBMS, you could actually outsource that to Hadoop and then get the results back into your RDBMS, right? So you could replace your ETL on RDBMS with ETL on Hadoop. Another case for Hadoop is to using HDFS as a cheap storage for archived or historic data. So you could probably use HDFS to store those transactions that are not actively queried upon but still need to be stored and occasionally queried upon for compliance or legal purposes, and you need to export data from relational databases to HDFS for that purpose. Now let us get down and dirty and quickly see how we can import data from relational database. Before that, we have a couple of prerequisites to fulfill, and both of them are very obvious. First, you need to have Sqoop installed on a machine. Secondly, you need to set up a relational database to connect to. So for the first requisite, that is installation of Sqoop, since Sqoop is not a cluster service, you do not need to install it on all the nodes in your cluster. It could actually be installed on any single node in the cluster or on a non-Hadoop cluster machine as well. But since it is a Hadoop installation, Sqoop requires that the Hadoop libraries and configurations must be available on that non-Hadoop cluster machine. Now first, let us set up Sqoop on our cluster. For that, we have to first download the install files from this Sqoop's site. So go to that link and then right click and copy the link of the version of Hadoop that you have set up. So which in our case is Hadoop 1.x, and the Sqoop version that we are going to use is 1.4.4. So let's copy this link address. So then we can download the files using the wget command like we have done previously. So here I am at the console of the virtual machine which I have logged into using putty. So let me just type the wget command. So it might take a couple of minutes to download. Now once the download is successful, let's look at the directory contents. So we see that there is a sqoop tar.gz file. So let me go ahead and unzip this one. Okay, once it is done, let me list the directory contents. So we have a directory as well. So for the sake of ease, let me rename this folder to just Sqoop. Okay, so let us look at the contents of the Sqoop directory. So as you can see, you have the usual folders bin, conf, lib, etc. So if I look at the contents of the bin directory, so you have the Sqoop executable which will be used very often. So remember the path of this, and now we can directly use Sqoop from within the extracted directory without any additional steps. But before that, let us go ahead and update our bash rc file with the Sqoop home directory so that we do not have to always be in the extracted directory to run the Sqoop executable. So to do that, I'm just going to edit the rc file, bash rc file. I'm just gonna type sqoop underscore home is equal to the path of my Sqoop directory, and then I'm just gonna append to the path variable. With the path of the bin folder. Right, I can just save and close, and now let me quickly run this to confirm that the changes have been made. And let me do a echo. As you can see, the Sqoop underscore home variable is now updated. So now in order to run any Sqoop command, I do not have to always be in the Sqoop directory. Now the next prerequisite is basically that we need to set up a relational database that we need to integrate Hadoop with. So we'll be using MySQL or MySQL database to demonstrate the use of Sqoop to integrate Hadoop and relational database management systems. As you all know, MySQL is the world's second most widely used relational database management system. It is open source, reliable, and it is very easy to use and set up as well. So let us go ahead and set up MySQL on our virtual machine. For that, let us type the below command. Update and type the password. So we already know the command apt get update, and we know that it basically synchronizes a list of the available packages with the servers in the source repositories, and apt get upgrade basically then downloads and installs any new versions of your installed programs, right? So once this is done, we could go ahead and install our SQL Server and client. So just type in yes, pause. Okay, now after the sudo update and sudo upgrade commands have run successfully, which actually took a long time, maybe because of my internet connection. Okay, we'll now then install MySQL Server and client. Okay, so to do that, the commands that we're going to use are sudo apt get install MySQL server and MySQL client. Type the password and prompt and type yes at the prompt, and then it's going to again take some time to download the MySQL Server client install files and then install it for you as well. Now you will be prompted to provide the password for the root user as well, so make sure you provide a password that you will always remember, and provide the confirmation, and now the installation will continue. Now once the installation is successfully complete, you can access your MySQL server using a root user you just created using this command: MySQL -u, the username, -p. It will prompt you for the password, and now you are now in the MySQL shell. So from this point onwards, you are working within MySQL until you exit the application using the exit command. So let us perform some MySQL operations. So let us quickly do a show databases. Okay, there was a typo, so let me change that. Okay, it shows that there are 3 databases: information schema, MySQL, performance schema. So let us use MySQL database to perform more SQL operations on top of that. So I type the command use MySQL. So it shows that the database has changed. So let me list out the tables using show tables command. So it lists out all the tables that are present in the MySQL database. Now let us create a sample database that we are going to use for import and export feature, right? So the syntax for creating a database is very simple. It's create a database. I'm just going to give the database name as sample. Okay, now let us add a new table. For that, say create table, says departments is the table name, and department underscore number is the first column, and it is of data type char, and the second column is your department underscore name, which is of the data type varchar, so 40 characters, and type OK. So now let me insert some values into this table. So insert into departments values, it's varchar, so I'm going to type in D01 and then the department name is say finance. So as you can see, a row is added. Similarly, I'm going to add more rows into this table as well. Before that, I actually have to change the database, so use sample database change. So let me now perform my select query. Start from departments. Again, there's a typo, apologize. Okay, so there's an error. It says that the sample.departments does not exist, and that is correct because when I created the table departments, I had not switched databases, so I was still under MySQL database. I'm going to eventually move the table departments into the sample database. Let me quickly do that. So right now I am in say sample database. Let me create a table by rerunning the same commands that I did previously. Okay, and I'm going to run the insert commands as well. Okay, and let me insert few other rows as well. So now let me confirm that I have the departments table, and then let me quickly query from that table. Alright, there you can see that the rows that I have inserted into this table are already available. Now what that does is it has given us a relational database to work with in order to explore Sqoop import feature provided by Hadoop. Now in order for Sqoop to be able to connect to this MySQL database, it requires certain JDBC drivers. So in our case, for the MySQL database, right, I need to download the corresponding JDBC driver. JDBC is basically a Java specific but database vendor independent interface for accessing relational databases and enterprise data warehouses. So if you have an application that needs to integrate with a database, you need to ensure that you have a JDBC driver for that specific database. But due to licensing, the Sqoop project itself cannot bundle the drivers in the distribution. So we'll need to download and install each driver individually. Most database vendors make it available as a free download from their websites. So for MySQL, you can download the JDBC driver from this link. So this is the link from where you can download the JDBC driver. So once you have downloaded the JDBC driver, ensure that you copy that into the sqoop/lib folder in your virtual machine. Now I have already downloaded the jar file and I have placed it in the Sqoop's lib folder. So let's quickly confirm that. So this is the MySQL JDBC driver, right? So now you are ready to connect to the MySQL relational database and import the data. So with that, we come to the end of this. In this video, we basically looked at where Sqoop can be used in a Hadoop deployment and also how to configure Sqoop and a MySQL database. In the next video, we will be looking at performing some import operations. Thanks for watching.